YouTube, we're back. Part 8 of the ASW-28 by Volantex. Get yours at Banggood. Check the description below. We're going to show you where we are right now. Got some ailerons working. Got a little bit of differential programmed in. Got some flaps. Note the full lengthness. Stabilizers on. Got to move the actual receive support, as you can see, for flaperons. That's how you can tell there's support for flaperons, because those are two different channels, and then these are a shared channel that's split off on auxiliary 2. And then this is the aileron, and this is the auxiliary 1. And then the gear channel is left open right now because we're not going to need that channel for anything else on this particular model. Similar to what we did on the ASH-26, except that on the ASH-26 we needed a retractable gear. So anyway, where we left off, we were working on getting the geometry right on all these things, and basically I just mimicked the setup from here to here on this wing, and I didn't want to bore you with all the details of that again. If you want to watch it, just mirror your screen and watch the last videos, 2 of them. For now, what we're going to do is we're going to pick it up where we left off, and what I have originally had planned on doing was getting some LEDs in here. And so that's what I'm tempted to do, but before I do that, I really want to get this tail done because it's so close and it's so ready and it's starting to look like a plane, and I'm really excited. But then I come back to Realityville and I say, wait, if I do that, then it's going to be really hard potentially to chase wires and all that. So we are going to do the LEDs first on the wings, okay? So in order to do that, we'll go ahead and power everything off. I just wanted to give you guys a quick look at where we were in terms of progress. And you may notice that I still have gaps here between my control surfaces and the wings. And I think what I'm going to try is, initially we're probably going to do just like a high quality tape, and then we'll come back and insert some other sort of foam if we need it, and that'll hold down on weight, but it'll still give the full aerodynamic effect. Also, you can see I was able to duplicate this quite easily, and at some point I'll go ahead and trim those down. So getting back to the point, now LEDs on these airplanes, as you know, I've kind of made some different changes on the way I do these things. But essentially what I end up doing most of the time is I will take a surface mount light, and like these LEDs here that came out of a billboard, and I mean, you can get them out of I had somebody commenting on the channel here the other day about taking apart a backlight on an LCD television, flat panel TV, and they were able to take the LEDs out of that. You can get LEDs out of tons of different things, but the other alternative method is I get these strips like this, and I usually desolder these. These are surface mount or SMD devices, as opposed to, you know, like a resistor. This would not be a surface mount because it's got pins coming off of it. So anyway, we're going to have a red, a white, and a green LED. So I've got the green here, and I've got the white. Now I'm obviously going to cut that out so it's not so bulky and ugly. And the other thing too is, a lot of times what I've learned is that I can use a couple of these will make for a very bright light, okay? But it's a lot more work to do it and do it nicely. But being that this is a foamy and this plane is fairly big, and I'm going to do the same thing with the white lights. And when I say 2 lights, I mean they're going to be configured together. Now, like I did on this ASH-26, I've got 2 of them here, and that was a humongous pain in the butt. This one's going to be a lot easier because I'm less concerned about the final look, being that it's a foamy, and that's a composite plane. But it should be fairly easy because what we're going to do is we're going to tap power right here. So basically, we'll just peel this. This looks to be just regular vinyl electrical tape. We'll just peel that back. There's actually decals that come with this plane to cover all that up. and we'll get to that eventually, but for the moment we'll go ahead and just flip this that way, and then we can lift this out of this little channel. It'll be really easy to tap power, because we could either do a Y splitter, but I mean, in my case, obviously I'm not going to do that. I'm just going to desolder or solder something in to tap it. So I'll just show you how we get this out. Don't be afraid to ding up the foam here, it's going to get covered anyway. So once you have it pulled up like this, then you can, sometimes you can pull the slack back towards you, but this one's glued in and wraps like that, so you're not going to have a ton of slack to work with. So the challenge becomes, do you want to tap the servo cable going to the actual servo, or do you want to tap this? And I mean, ideally you would tap this, because if you have a servo that fails, which I'm going to be the first to admit, these are all plastic gear servos. That sucks. I want to see metal gear servos in a plane this size, but whatever. If they fail, the price point doesn't really allow for a bunch of metal gear servos, and I will be glad to replace these with Emax metal gear servos. I think they call them a 12-gram servo, but they're like a 9-gram size. So we'll do that if we ever have a failure. But for the moment, we'll either tap these or we'll tap this. And I haven't decided yet, but that's how we're going to get power from here. And we're going to run at receiver voltage. And as you guys remember, this YEP ESC has a 5.5 volt at 4 amp power supply SPEC. This is just in fact, that might be the Volantex one. No, that's not the Volantex one. This is an ESC that's at 5 volts at 3 amps, which is a more common size. It's not going to be that big of a deal in terms of the difference on intensity on the LEDs, so we're going to go ahead and use this for testing like we always have. And it doesn't, or well, it shouldn't matter what size LiPo we plug into our screwed up ESC that I use as a BEC. Shouldn't matter in this application, so we'll use that again. So anyway, that's the quick overview on this project, and of course we're going to have to cut a channel to get our wires over to this approximate area. Yes, there are winglets, and I had considered the possibility of taking these winglets. Now these are pretty stout, but they're still a vulnerable point on the plane. But if I were to do this, I thought about it long and hard, and I decided if I were to do that, there's no way to get around kind of having ugly wires on the outside. And furthermore, where do navigation lights go? They go on the leading edge of the wing, and they're supposed to point out like this. Okay, now in my case, I want them to point like everywhere so I can see, regardless of the direction of travel. I want to be able to see, to triangulate the location from the tail light to the nav lights. Whereas in real life, you would be able to tell the direction or orientation of the plane by not only the color of light, but how much of the other lights you can see. So we'll put them over here. We'll probably pick a spot that's just in from the edge. So maybe we'll go midpoint between this, where it kind of tapers down. So we'll go something like this. That keeps all of our work nice and neat. Now the other thing is, this wing is nice and thin here, whereas of course when you get back here it's thicker, and then on the winglets it's just kind of changes and gets really thin. So you have a little bit to work with, but it's not so thin that, that you're not going to be able to hide the LEDs. So that's the idea. And now if you guys don't like doing all this desoldering, you can actually buy these and just leave them in 3-piece chunks, and then you can wire them up to 12 volts, which would be a 3S configuration in this case. Now if you run a 4S, you're going to probably burn them out, so just be aware of that. But what you would do is you would just take and tap your ESC here, positive and negative, and you would run separate lines out to each of those points. But keep in mind, you're going to have to come all the way down, and then every time you plug and unplug, you're going to have another connector, like a JST connector or something of the sort, if you want to be able to remove the wings. On my old ASW, I ran 12 volt LED strips, and I wrapped around the front and then up the surface. And they did work really nice in that application, but even the 12 volt lights are not bright enough in my opinion. So without further ado, we're going to get going, and I'm going to start desoldering these things, and we'll probably give you a little taste of that. We're not going to have you watch all of it because it's super boring. Okay, so I just tore off this packaging from this, and I'm down to the PC board level. And as you can see, there's two surface mount LEDs here, and just to juxtapose the size here for your comparison at home there, these LEDs are maybe 3 times as big, but these LEDs are maybe 4 to 5 times brighter, a lot brighter, and that's why they're worth the trouble. Actually, my father-in-law got these on a job that he was instructed to take down an old sign. They changed a company logo or whatever, and so anyway, he gave me a big strip of them, and they work nice. In fact, this is what they're supposed to look like. I put this power supply in here. I forgot I had this in here, and this is before I did all my lighting upgrade in the shop, and this is what they're supposed to be. It's just like this, and did a little 24-volt power supply. You can unplug it, and that's what they look like. But in my case, of course, I'm going to be taking them apart, and I will make them brighter doing this than they were ever probably intended to be, but not to the extent that they get hot. If they get hot, then they will burn out prematurely. Okay, so that's the idea is with these LEDs. Most LEDs are going to be sized for usually like 2 to 3 volts DC, no matter what circuit they're on, because that's the way the diodes work. And so there may be some circuitry in there to get the voltage low, but that's why it works so nice to run these off the receiver voltage, because you're bleeding off less through your current limiting resistor, less power, and then you get more light, more bang for your buck. And so what I'm doing now is I'm just kind of splitting these down, and some of you may have seen this in other videos. If you have, I'm sorry, I don't mean to bore you. Skip past this if you need to. Basically what we're going to do is we're going to take and trim down this backing material, and then we're going to be left with just a small amount of material, and I might sand it down with a grinder, a little Dremel tool style grinder. Now you could try to desolder these, but my experience has been that when they're this small, it's about impossible to do that. Sure, you could probably do it if you really were motivated, but I'm not going to encourage you to do something that I have a hard time doing myself. There's lots of people that are better solderers than I am, though, so don't let me stop you. Okay, so once we get these trimmed down, then I'll just do the same thing for the second LED, and then we'll figure polarity, and I'll show you how to do that. Let's pause it for now, though. Okay, so I got 2 of these things ready to rock. So we're going to plug in our power supply here. Our electronic speed control that's no longer being used as an ESC. The brushless motor drive portion is dead, so I just use it as BEC. So now what we have to do is we have to figure out polarity, and that's the next step. Is I'm going to go ahead and grab some positive and negative voltage via just some current limiting resistor here. So we'll go ahead and size that real quick, and when I say size, we'll go ahead and grab whatever's convenient, but large enough to guarantee we're not going to damage the LED. So we'll just go with a 470 milliamp, or excuse me, 470 ohm resistor, and that goes between the negative, okay, because the electrons flow from the negative to the positive, which is a common misunderstanding among people who don't have a lot of electronics background. No problem. And okay, so now this pin is lined up there, so we can go ahead and tap into it. We'll just grab a little bit of wire. And basically what we're going to do is we're just going to touch both sides. Now, once you have a current limiting resistor in your circuit, you don't have to worry about burning out the LED, okay? It's not going to damage your LED. Now, that's not to say that you should just be completely reckless with it either. If you use a 1 ohm resistor, you're probably going to burn the LED out. So, because you're not going to have enough current limiting resistance. Okay, so this is a solid core wire. That makes things easier. So this will be our positive side just because it happens to be red, okay? And so obviously touching it's going to do nothing because there's no completion of the circuit there. So now we just need to find a little something that we can use as a negative and close the circuit. Okay, looks like this is a braided wire. So I may have to go ahead and tin this up. So I got my soldering iron nice and warm. We'll stick it in some flux. We'll get a little bit of solder up against the tip of the exposed portion. That's called tinning. Okay, so there you have it. Now that that's cooled a little bit, we can go ahead and what we'll do is we'll run this up right over here just to make it convenient, and then anywhere along this row or strip we can plug in. Okay, so now the objective is to just determine polarity. It's not necessarily to wire this up permanent. Okay, so that's wrong, or the LED's bad. Or I have too big of a resistor, which is always a possibility. I'm just double checking I have everything the way it should be. Okay. So that didn't do anything. Now I'm starting to wonder what the heck is going on here. What did I do wrong? Maybe this is like 470 k ohm or something weird like that. Let's try a 220 ohm resistor. Okay, so we'll stick that in there. We'll bring it over to this strip. Actually, we'll move it over one strip just in case. Nothing. And still nothing. Well, that sucks. I wonder if it's dead. It's always a possibility, guys. Or there might be too much oxidation on this line or something weird like that. Okay, so now we need to do some investigation and figure out why we're not getting voltage. Sorry to drag you guys into this. Okay, so we got our power coming off. Obviously we have some LED lit up here, which means we got a little bit of juice at the circuit. This one's hooked up, but it's not actually terminated. Okay, and then we have power here. Oh, you know what it might be? That's actually going around to this side here. So unless I accidentally detached the wrong wire, which it appears that I have. Okay, so what that means is that I actually have power that's jumping from one side of the board over to this strip. And you'll notice none of my lights are on. Well, that's because I don't have the circuit completed. Let's test. Yep, so we have red flashing lights, so that means we do have power on this rail. Okay, so now we need to figure out why these LEDs aren't turning on. So what we can do is we can go ahead and test on another one. Now that we know the polarity because it's labeled right there. Yep, we've got LED. So that would really stink if we killed both of those LEDs. I haven't done that many in a long time. Okay, so we obviously have power there. We know the polarity is correct as it's silk screened on. Okay, so it looks like positives on our left on the green. These are the green ones. Okay, there you go. So there's your green. There's your green. Okay, so those are working. So now maybe I'm not making contact. Maybe I'm just not pushing hard enough. There we go. So the polarity is correct there. Maybe, guys, I just wasn't pushing hard enough. Yep. Okay. So we've designated the polarity to be correct or appropriate. Now we just need to mark one side or the other. In this case, I'll probably go ahead and mark this side, which is negative. Okay. And that'll just give me a reference for later, so I don't have to redo that when it's all installed. Not sure what I was doing wrong there, guys, but evidently I was doing something wrong. Okay, so now the next thing we have to do is, let's do a quick size comparison on this LED to the body of the plane. And when I say the body of the plane, I mean the tail area. My hope is to have the light down here in similar configuration to what we did on the ASH-26. And you can see that you can easily fit two of those here. If I could just mate up the negative side and then have a positive wire that goes around either side, then we can share one current limiting resistor for two of these just fine. Now the idea is, you see the way that this rudder is going to fall down. It's going to go down so that it's like right there. Well, if I have those right where my pinky is, pointed down and out, you'll still be able to see the LED, but I'm not going to obstruct the rudder's function at all. So we'll go ahead and do that, and you see how we got the black marks there, so we'll just put those side by side, and we'll go ahead and get a little bit of wire that we want to use, and we'll make this almost into a, we want to make them flat at a slight angle probably, okay? And the rationale behind that is so that when we go to mount it to that curved surface, they'll point down and to the rear of the plane. You don't want them to be down, just point straight at the ground. That's not going to be very effective as you're flying away from yourself. So we'll do it like this. And if you wanted to, you could put the current limiting resistor straight off of there. But obviously we've proven that the 220 ohms is just, it's too much resistance given the circumstance that we're working with. So what we'll do is we'll try 100. You see how this thing's fairly small? You see how that one's fairly big right here, but then this one's small? Well, it says 100 ohms. Now, obviously, I could test that with a multimeter. And you see how those ones are like really dinky? Well, this, I believe, is 1/8 of a watt, and these are 1/4 watt, okay? Or, excuse me, this might be 1/4 watt. These are 1/8 of a watt, meaning the power handling before they fail. And then over here, I believe these might be 1/2 a watt. But either way, it doesn't really matter that much in this application, because we're just going to guess and check until we make sure it doesn't get hot, okay? So we'll guess and check real quick together before we get this all soldered up. Except that we have to tie those together for our test. So let's get some wire and we'll come right back. Okay, so I got a little twisted wire. This has multiple strands, which helps the solder to take up a little better. And what I do is I take these parallel, these 25-pin connectors, which would actually be a serial connector. This would, I believe that's a parallel connector. But they have a super small strand in there, and they got a bunch of different mating pairs, which is super nice when you're doing this. So I'm going to just take that. You don't need a real long wire for this application, because we're just going to be basically going into this hole and then coming up and tapping one of these two. It doesn't matter which one. However, I would recommend you tap the rudder. If you have a failure on this plane, even though a rudder is very critical, I'd rather have my rudder fail than my elevator fail, especially because of a stupid wiring thing. So that's not to suggest that there's going to be a failure because of this wiring, but you know, people make mistakes. So I'm going to go ahead and assume I could make a mistake and make decisions based on that. So here we go. So we'll untwist a little bit of this. And what I want to do is I want to take power from this side and that side, the positive from here and here, and then I'm going to take negative from the center. So what we can do is actually bridge the solder right now, but then that's going to cause a problem because then we need to get this wire for positive from here to there. So I'm going to do the positive first. And by the way, I wonder what the heck size this resistor was, because everybody at home is probably wondering, what the heck, what did you do wrong, Brian? I'm going to put it in 2000 ohms setting on my multimeter, and look at that, guys. Look at that. It's showing open. So I wonder if I had like a mega ohm resistor or something like that. There's 200K, and look at that. Oh, buddy. 400 and... Jeez, how big is this thing? That's in the 2000K ohm. That thing is gigantic. So it is a 474, but it's just a... I must have missed a ring. So that's basically a gigantic resistor. It's got tons of resistance, almost like an open. It's almost like having your wire disconnected altogether. So I will be taking those out of that row and moving them later. That being understood, what I need to do now is go ahead and figure out giving myself a little bit of slack to get from here down. So I'll strip that area right next to my thumbnail on my left thumb. So just grab the strippers, and this is just a little trick that you can do is you'll strip from way up here, but you'll just expose the wire, and then what you can do is brace that and then slip it off the end. Okay, and that gives you the ability to go ahead and tin in the middle without actually cutting the wire, and that makes things a lot easier. Okay, and since this is a braided wire, it is quite a bit easier to do this than if it was a solid core wire, like a motor winding wire. Okay, so we're going to dip that into the flux, the tip cleaner. We'll do a little mechanical cleaning. Okay, we've got a nice clean tip. And then let's tin this. Okay, so we got a little wire. Whoops, got a little solder going in there. It's kind of mad at life right now because I got it really hot. So what I'll do is I'll actually attach it right here and then try to pull that sheath back up. tricky because sometimes the LEDs will try to walk away from you. And so you'll have to figure out what works best to get that thing to hold still. Sometimes put something heavy on there is enough, but it's just, nothing ever seems to be the right size. Or it's the right size and it just blocks access to where you need to solder. Helping hands are great. I've just found that the helping hands usually don't help as much as you'd want them to. Okay, here we go, guys. Okay. Oh geez, of course it's out of focus the whole time too. Why would you guys want to see anyway? Okay. So we can go ahead and let that go. And I would say that that's probably a pretty safe bet that that's going to be good. And then here in a minute, we'll actually cover this all with CA anyway. So if you have a little bit of exposed tinned wire here, it's no big deal. Of course, it'd be better if there weren't, but, you know, reality bill. Okay, so I'm grabbing the tinned end here, and I'm going to just pull back on this cable a little bit. See how it slipped? That's what we wanted to happen. That little burn mark is no big deal. It doesn't really matter. It doesn't hurt anything. It's not going to make a difference in the application. So now I'm going to try from the other side here. I'm going to just grab this and pull that wire back down. You see how that worked, guys? Nice. Okay. So now remember, we're going to, ultimately it's going to be shaped something like that. So I need to now wrap this around. And let's see if I can get up here and get the angle. So it's going to be almost like a weird looking mechanical smiley face. Okay, so that's going to end up being flat right there. Okay, so I no longer have to worry about what direction it's actually facing. I'll do it after the fact. Okay, so we can solder this first. Little flux, little cleaning, little tip cleaning, little flux, a little bit of solder, let it wick in, let it wick in, and I hate it when solder doesn't flow right. And when you use old crappy wire, it doesn't always flow very good. Make no mistake, when using free wire that's been stripped, that's like 25 years old, it's usually probably not going to take solder as good as you'd like it to. Okay, so this is probably going to block your view. I'm going to try my best. Okay, holding it down with the strippers. And then the positive side is toward us, but we need this to actually be the other way. It doesn't matter, we'll just rotate it. This tip is dirty already. Okay, nice clean tip-ish. It's actually not, that's why I'm doing this more. Yes. Okay. Now I can holster my weapon. Just kidding, YouTube, it's not a weapon. Okay, so now, see how I did that kind of backward? Well, that was on purpose because now I can rotate it around. Oh, dang it, I might have done it backwards still. Son of a gun. So let's redo that real quick. Get something heavy on there. Get the tip clean. Go into autofocus mode. And desolder it, okay? Now I need this wire to go the other way. Like this, okay? Sorry about that, guys. Got it. Okay. Oh, that son of a gun. That was a premature pull away. Watch out for that. Well, it depends on your application for that. That's a good way to burn up your LED, so just be careful. It feels like it's mounted, but I don't think it is. We'll see in a second. Alright guys, so now we'll go ahead and rotate that around, and now we got our weird looking smiley face again. And now we just need to solder those two together, but we can clip off this excess now. Meaning this part here, okay? Alright, so the next step, of course, is going to be to get this negative line trimmed, preferably with some twist in there so it mimics the look of the rest of the cable. One less. Okay, now we're going to strip that to the appropriate length, which should be here. Now this one we don't need to cut in the middle because we're not going to two places, we're going to one place. Then we can cut off the excess. Okay. Then we're going to tin this and we're going to get that thing soldered. Okay. Okay, I'm going to cut that in half. I don't need quite as much. Alright, now this is where it gets tricky because you're trying to go between two different devices, okay? Never seems to work quite as good as I want. So I'm going to pause it and get this taped down. Okay, so now it's taped down and I just got to try to solder it. I have you guys out of autofocus, so you'll just have to grin and bear that for a second so that you can see what I'm actually soldering here. This little, I hate this fine-tipped soldering iron because it overheats so quick. Okay, so I got one side. Oh, son of a gun, now it's separating every time I try it. Okay, so I got them physically, get them closer together. Okay. Now it's time for Solder Blob City. That's hot. Okay, so there's another trick I'm going to show you guys. Let me get this wire ready and I'll come right back to you. Okay, so I took and powered this up, so I just terminated that instead of the red and black wire that we had. Now I just have this little chunk of wire that I'm going to use to bridge between the two LEDs. So I'm just going to kind of roll it up into a little, sort of like a small ball. And then I'm going to leave the tail on it so I have something to hold on to. And then what I can do is with this light in here, I can actually see when I'm making contact or not, okay? Okay, you see how it's turning on and turning off, okay? I don't care if it flickers right now, it doesn't matter, it's not going to stay on the whole time I'm doing this anyway. Okay, so now that that's held in there, just mechanically, I'm just kind of pushing it in there. Now I can heat this up and get this thing tinned into position, okay? Okay, so now it's on. See what happens to the LED when it gets hot is it just like shuts off. Okay, so now we're going to let that cool for just a second. Obviously we have to resize the current limiting resistor now that we have two in there. Okay, so now that it's had a chance to cool for a second, we're just going to make sure that it's not going to make and break contact a bunch with a little bit of pressure. And then we can take our tool and go ahead and trim. Make sure we don't short anything, okay? And then this little extra tail now can be eliminated for good, okay? And you can actually do that with the